Okay, mixed exercise 11.06 has 3 questions on integration, A-level pure maths, year 2. Question 1. Find the following. A. The integration of root x plus 1 over root x respect to the x between the limits of 1 to 4. B. Find the integration of cos 2x times sine 4x respect to x. So the first question, I'm going to rewrite the question. So I've got integral of square root of x plus 1 over square root of x respect to x from 1 to 4. This will be written as the integration of x to the power half plus x to the power minus a half respect to x from 1 to 4. Now I'm going to do my integration. If I integrate x to the power half, I'm going to add 1 to half to get 3 over 2. And I'm going to do 1 over 3 over 2. And I'm going to get 2/3 x to the power 3 over 2. So I will have, 1 plus half will be 3 over 2. 1 over 3 over 2 is 2/3. So I have 2/3 x to the power 3 over 2 plus. If I add 1 to this power here, I'm going to get half. 1 over half is 2. So I have 2x raised to the power half. And I put my limits in from 1 to 4. To make calculation easier, I'm going to factorize 2 out. So I'll get 2 square bracket 1/3 x to the power 3 over 2 plus x to the power half and real limits. So this can be written as 2 1/3 square root of x cubed plus square root of x 1 to 4. I can now do my evaluation by putting 4 in there and 1 in there. So if I do that, I'm going to get 2, and that's 1/3 square root of 4 cubed plus square root of 4 minus 1/3 square root of 1 cubed plus square root of 1. And then that can be simplified to 2 brackets 1/3 times 8, because square root of 4 cubed is 8, and that will be 2 minus 1/3, because square root of 1 cubed is 1, and then minus 1. Square root of 1 is 1. And then when you add everything in the brackets, you're going to get 10 over 3. So this will give me 2 times 10 over 3. And finally, you have 20 over 3, which can also be written as 6 2/3. And that is the value required. So that's A. For B, we need to rewrite this in a form that can be integrated easily. And I'm going to use 3 identities to achieve that. And the 3 identities I'm going to use is sine 2x is equal to 2 sine x cos x. This implies that sine 4x can be written as 2 sine 2x cos 2x. So I'm going to replace sine 4x with this. So cos 2x sine 4x will be equal to cos 2x times 2 sine 2x cos 2x. This can be simplified to 2 cos squared 2x sine 2x. So now this integration can now be replaced with that. So if I do that, I'm going to get integral of cos 2x sine 4x dx will be equal to integral of 2 cos squared 2x sine 2x dx, and with the limits from 0 to pi over 2, so 0 to pi over 2. Now I'm going to use substitution, and so if I say, so let u equals to cos 2x, that will mean that du is equals to minus 2 sine 2x dx. It also implies that minus du is equals to 2 sine 2x dx. We can now see that this 2 here and the sine 2x dx can be replaced by minus du, because we just found out that minus du is equal to 2 sine 2x dx. So this 2 will be replaced by minus du. And then, because we said u is equal to cos 2x, then this whole thing will be replaced by u squared. So we can now rewrite this integration simply in terms of u as follows. Integral of cos 2x sine 4x dx will be equal to minus integral of u squared du. As we explained over here, the u squared replaces cos squared 2x, and then minus du replaces 2 sine 2x dx. And now we can integrate this easily. But before we integrate that, let's put in the limits. For this side, the limits are 0 and pi on 2. So because we have said u is equal to cos 2x, we're going to change the limits to reflect that. So we can draw a table here as follows, with x here and u over there. So when x is pi on 2, if I put pi on 2 here, I'll get 2 times pi on 2. That gives me pi, and cos pi is minus 1. So the u will be minus 1. And then if I put 0 over here, I get cos 0. And cos 0 is 1. That means when x is 0, u will be 1. So the new limits will be 1 to minus 1. We can now integrate between those two limits. And if I integrate u squared, I'm going to get the minus outside. And I have 1/3 u cubed from 1 to minus 1. So now I'm going to put minus 1 here and 1 over there to do my evaluation. So I have minus. If I put minus 1 here, I'll get minus 1/3. If I put 1 here, then I'll have minus 1/3. That gives me minus brackets minus 2/3. So the final answer will be 2/3. And that is the final answer required. Question 2. Use the substitution x is equal to 2 cos theta or otherwise to evaluate the integration of 1 over x squared times square root of 4 minus x squared with respect to x between the limits 1 and root 2. Give your answer in said form. So we are given this substitution here. So we have x is equal to 2 cos theta. This means that dx is equal to minus 2 sine theta d theta. I will need x squared. So x squared will be, x squared will be equal to 4 cos squared theta. Now let's first simplify the denominator. So the denominator, x squared times the square root of 4 minus x squared is equal to 4 cos squared theta times square root of 4 minus 4 cos squared theta, because we said x squared is equal to 4 cos squared theta. And this can be simplified to get the following: 4 cos squared theta times the square root of 4 brackets 1 minus cos squared theta. This will simplify to 4 cos squared theta times 2, because the square root of 4 is 2, and then times the square root of 1 minus cos squared theta. But we know that sine squared theta plus cos squared theta is equal to 1, which means that sine squared theta is equal to 1 minus cos squared theta. So I can replace this with sine squared theta. So if I do that, I'm going to get 8 cos squared theta times the square root of sine squared theta. This means that the whole of that can be simplified to 8 cos squared theta times sine theta. So the whole of this denominator over here can be reduced to this. So the whole of the integration becomes integral of 1 over x squared times square root of 4 minus x squared dx equals to the integral of 1 over 8 cos squared theta sine theta. And remember, this dx we know is equal to that, so we can multiply that by minus 2 sine theta d theta. We can now do some cancellations to simplify that. 2 goes here, 1, and 2 goes there, 4. Sine theta, we cancel sine theta. And so the whole of that integration reduces to the integral of 1 over 4 cos squared theta d theta. And I'll put the negative sign outside here for convenience. But we have to change the limits. The limits for x are 1 and root 2. But we said x is equals to 2 cos theta. So to get a limit for theta, you can draw a table here and put x here and theta over there. So when x is root 2, I'm going to get cos theta is equals to root 2 on 2. And cos inverse of root 2 on 2 is pi on 4. So when x is root 2, I get pi on 4 here. When x is 1, I'll get 2 cos theta equals to 1. And cos theta will be equals to 1 over 2. Cos inverse of 1 over 2 is pi over 3. So when x is 1, theta will be pi over 3. So the limits will now be pi on 4 here and pi on 3 here. So this will be pi on 3. That will be pi on 4. So the whole integration becomes 1 over x squared times square root of 4 minus x squared dx will be equal to integration of minus 1 over 4. And I have 1 over cos squared theta d theta. But 1 over cos squared theta is sec squared theta. So this becomes minus 1 over 4 integral of sec squared theta d theta. So if I put the respective limits in, I have 1 here and root 2 over there, and then pi on 4 here, and pi on 3 here, pi on 4, and pi on 3. The integration of sec squared theta is tan theta. So my integration will be minus 1 over 4 tan theta between pi on 3 and pi on 4. So I'm going to put pi on 4 in there and pi on 3 over there and subtract them. So I'll get minus 1 over 4 tan pi on 4 minus tan pi on 3. But tan pi on 4 is 1, and tan pi over 3 is root 3. And so this is the answer, but it can be written as 1/4 brackets square root of 3 minus 1. And this is the answer required. Question 3. A. Find the integration of x times e to the power minus x dx. B. Given that y is equal to pi over 4 when x equals to 0, solve the differential equation e to the power x dy dx is equal to x over sine 2y. Now for A, I'm going to use integration by parts. And the formula required for integration by parts is integral of u dv is equal to uv minus integration of v du. So for this integration, I'm going to say let u equals to x, and therefore dv will be equals to e to the power minus x dx. If I differentiate u with respect to x, I'm going to get du is equals to 1 times dx, so I'll get dx. So now I have to integrate dv to get v. So v is equal to the integral of dv, which is the same as the integral of e to the power minus x dx. But if I integrate this, I'm going to get v is equals to minus e to the power minus x. So this integration becomes x times e to the power minus x dx equals to integration of u dv, which is the same as u v minus integration of v du. So that will be equal to u times v, which is x times minus e to the power minus x, and so I'll get minus x times e to the power minus x minus the integral of v, which is this one here, so minus e to the power minus x times du, which is dx. So now this can simplify to minus x e to the power minus x plus integral of e to the power minus x dx. This now becomes minus x e to the power minus x. Then if I integrate this one here, I'll get minus e to the power minus x. Then I'll add my integration constant. So this is the final answer, but we can write it by factorizing e to the power minus x up, and we're going to get minus e to the power minus x bracket x plus 1. and then you add your integration constant. And this is the final answer. So that's for A. So for B, they're going to solve this differential equation. So we can separate the variables. So what I have is e to the power x dy dx is equal to x over sine 2y. If I separate the variables, I'm going to get sine 2y dy is equal to x over e to the power x dx. I can rewrite that by bringing this one up here, and I will get sine 2y dy is equals to x e to the power minus x dx. I can now integrate both sides. Then if I do that, I'm going to get minus half cos 2y. And notice that this integration is the same as the one we did in part A. So we're going to use that integration that we did, and that we know is equal to minus e to the power minus x bracket x plus 1, then integration constant. We are told that when y is equal to pi over 4, then x is equal to 0. So I'm going to do the substitution in this equation to find the value of my integration constant. So if I do that, I'm going to get minus half cos pi on 2, because 2 times pi on 4 is pi on 2, will be equals to minus e to the power 0 brackets 0 plus 1 plus the c. Now cos pi on 2 is 0, so the whole of this left hand side is 0, so I have 0 is equals to, and on the right hand side this e to the power 0 is 1, so that's minus 1 times 1, so I get minus 1 plus c, which implies that c is equals to 1. So now that I've got a value for c, I can write my full equation as follows. So I have minus half cos 2y is equals to minus e to the power minus x bracket x plus 1 plus 1. So that's my equation, but I'm going to rewrite that by multiplying both sides of the equation by minus 2. So if I do that, I'm going to get cos 2y is equal to 2 e to the power minus x bracket x plus 1 minus 2. I can now factorize 2 out. And so if I do that, I'm going to get cos 2y is equals to 2 e to the power minus x brackets x plus 1 minus 1. And that's the final answer for B. And this brings us to the end of this session on integration for mixed exercise 11.06.